Myself, Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today, we are going to discuss about labeling survey. So, let's start our lecture 5th for this chapter, right? What we are going to learn in today's lecture. So, in today's lecture, we are focusing on a very important term, the contour. And then after we will follow it by knowing its characteristics. And lastly, we will see some applications of contours. So now, without wasting much time, let's start with our first topic, which is introduction of contours. So here, the first term that we are going to understand is contour and contour line. Secondly, we will discuss the contour interval. And lastly, we will see the horizontal equivalent, right? So let's understand first the term contour and contour line. So here on screen, you can see a contour may be defined as an imaginary line passing through points of equal elevation or RL. Here on screen you can see one example of a hill. It means a hilly area. Here, as you know, in the hilly area, the topmost point having the maximum elevation. Here it is of 80. Then it is fall by 75, 70, 65 and 60 when you come to the foot of hill. Now, when I join the points having the same elevation, that is clearly shown over here, that line is known as the contour line, and that overall map is known as the contour map. And now you know that contour map or contour survey are very useful to decide the topographical condition, that whether it is okay or not for the civil engineering work, right? So I can say it can be also defined as the intersection of a level surface with the surface of earth, right? It is a representation of vertical distance in 2D maps, and it shows the topography of the area, as I said, right? Here the example says that a contour of 80 meter indicates that all the points on the line have RL of 80 meter, right? Now let us understand the second term, contour interval. So here contour interval is something where the vertical distance between any two consecutive contours is known as contour interval. Here on screen you can see the valley example is given, in which the points are of 87, 88, 89, 90, 91, right? So here the difference between two lines, it means 90 and 91, is known as the contour interval. So here generally it depends on the nature of ground, scale of map and purpose of survey. So how it will affect? So generally, if I talk about the nature of ground, for flat ground, the contour intervals are of 0.25 meter, 0.50 meter and 0.75 meter. If it is a steep slope, it means a slope is there, then the interval is of 5 meter, 10 meter and 50 meter to get the exact accuracy of that slope over that area, right? Then if I talk about the scale of map, it means a small scale and the large scale. For small scale map, I will go for the interval of 1 meter, 2 meter and 3 meter. But if it is a large scale map, then I will go with the 0.25 meter, 0.5 meter and 0.75 meter. Lastly, the purpose of survey plays an important role. If I go for the highway and railways construction, at that time the contour interval is of 2 meter, where the length is there, right? But if I go for the building a site, dam or earthwork, it means a very precise work I have to do. At that time, I have to go with the minimum interval, it means 0.5 meter. So here, according to the site condition, according to the purpose of survey or the work what we want to carry out or the nature of ground will affect that what should be the interval between two consecutive contour lines, right? So that is the concept of contour interval. Now, let us understand the third term, horizontal equivalent. So, what is a horizontal equivalent? So, generally here on screen, you can see that this is the valley and we are trying to draw the contour lines for that. So, horizontal equivalent is something that the horizontal distance between any two consecutive contours is known as the horizontal equivalent. Here on screen, you can see that it is not constant. Here you can see the difference is not constant. It varies on steepness of the ground, right? So contour interval is something different and horizontal equivalent is different, right? So it is depend on the steepness of ground, right? So this is all about the basic three terminologies related to contours. Now let us understand the second topic for today's lecture, which is of characteristics of contours. So to understand the characteristics of contours, there are various points available, in which the first characteristic says that all the points on the contour lines have the same RL, because the definition of contour says that it is an imaginary line passing from the same elevation or RL. So if I want to draw the contour line, I can represent it with two types. In the first method, here you can see that 100 is mentioned in a circle, or in the second method you can see you simply put the value 100 in between the contour lines. So these are the two specific methods to represent contour lines, right? Now in the second point we can say if contour lines always form a closed circuit, then what about the dotted lines shown over here? Because sometimes line may be within or outside the limits of the map. So contour lines must close itself but cannot end on the plan. It means I am trying to say if I am drawing the contour map for Ahmedabad, but the points having the same value can continue in the Gandhinagar also. But now my area is restricted, so it is possible that line is not completed in this map, but it is continued in such a way that it continue with the other extended area. But for better understanding, if I want to join the whole circuit, at that time the outside area should be marked with the dotted line, but the inside area should be a closed circuit and in a complete line. That is the second characteristics of contours. The third characteristic says the uniformly spaced contour lines indicate the uniform slope. Here on screen you can see that 10, 20, 30, 40, 50 is the distance having an interval of 10, and the uniform slope is present if the lines are uniform to each other. It is purely depend on the nature of ground, right? Now the fourth characteristics is all about contours do not have sharp turnings, because we are trying to connect a contour closed loop, right? But we are not trying to join the points with angles, so there is no possibility of sharp turnings, right? Closed contour lines with the higher value inside always indicates that it is a hill. Here on screen you can see in this figure it is a hilly area, and as I said, the apex point of hill having the maximum elevation. So here on screen you can see it is of 637. Whenever you come to the foot of hill, then the value decreases. So the outer lines value are lower than the center one. Whenever you read a contour map having a center point as a higher value, it purely indicates that it is a hilly area. Same way, the lower value inside indicates that it is a depression, because it is the opposite example for this hilly area. So here then the lower portion is in center. So the lower portion 86 is in center. Then it is increased, and as you go the bank of a river, so then it increase up to 100 as shown in this figure. So that is very important to understand or to read any contour map, right? That it is a hilly or valley condition, right? Now the next characteristic says that contour lines are close near the top of the hill and wide apart near the foot. As I said, the slope is steeper in the peak, but when you go to the foot, it tries to get flatter. So here in this figure, you can see the lines are congested because the slope is there. As the slope decreases, the lines having more spacing than the peak portion. So it is all about hilly area. Here again you can see the center value 105 indicating that it is a hilly condition, right? Same way, contour lines are closer near the bank of the pond and wide apart towards the center, right? So this indicates the steeper slope near the bank and a flat slope near the center. It means a flat slope near the center and a steeper slope at the end for valleys. So here again you can see a value 100 which is in center is quite lower than the outer side value, which is clearly shows that it is a contour map for the valley area, right? So this is the characteristics of contour for knowing the slope of hilly and valley area conditions, right? Now, let us understand the eighth characteristics, which says that contour lines meeting at one point indicates a vertical cliff. Now, generally, contour lines having a specific value, so they can't cross each other, but they can meet at one point based on the topography of that area. So here on screen you can see that all the points or all the lines are meeting at one point. Now whenever this kind of topographical condition arises, right, that is known as the vertical cliff, right? Next is the overhanging cliff. It means, as I said, that two contour lines never intersect with each other except overhanging cliff. It means what? In specifically overhanging cliff condition, here you can see on screen that curve having the value which are overhang to each other is known as the overhanging cliff. So this kind of condition has chances where the two contour lines can be intersect. Otherwise, they cannot intersect with each other, right? So that is all about overhanging cliff. Now, the 10th one says that the contour lines deflect at valley line and downhill at ridge line. So here you can see U shape is indicating that it is a ridge line and V shape is indicating that it is a valley line. So here you can see the ridge line, it means a line passing from the apex points, right? Same way valley line passing from the apex point. Now in the ridge line portion in the figure 1, you can see the center value is of 100, then it is decreasing. It means it is a hilly area. And for valley line, you can see the center value is the lower one and the outer value is the higher one. It means a valley area. So this is the indication for ridge line and valley line having a specific shape. Now, this is all about classification of contours. Now, let's understand the last topic for today's lecture and for this chapter, which is of application of contours. So, basically, there are various applications of contours in which the first application says that these are used to select the site for engineering projects such as road, canal and railways, right? That we have already learned in surveying, right? Now, the second application says that we can use this to find the possible route for communication between different points. It means simply making or connecting bridges, roads, railway, canals, anything where the height perspective comes in picture, right? Third application says that to compute the capacity of the reservoir and the area of submergence. Whenever the height terms comes in the picture, when I am talking about a reservoir, it means the backward portion of a dam where the water is stored. If I want to know the area or the capacity of that reservoir as well as the submergence portion, at that time height I have to identify. It means I have to deal with the contours, right? Now the fourth application is to find the intervisibility of stations. So whether these 2 points are intervisible or not, right? Now let's understand the fifth application, which says that we can fix or obtain the profile of ground surface along any direction, right? So that is again an application of contours. Sixth one is all about to mark suitable route for a given gradient on a map. It means we can identify or we can provide this slope according to the level difference, right? Seventh, we can say that to estimate quantity of cutting and filling. Again, it is also dealing with the height difference. So this is all about application of contour. I hope you all understand these 3 terms in detail, where the contours, its characteristics and its application are very important for exam perspectives, right?